As we have already discussed about addition laws of real numbers in our previous video, so today's video is about multiplication laws of real numbers. Let me tell you something that both multiplication laws and addition laws of real numbers are almost same, but there is a minor difference between both laws. So let's start with multiplication laws of real numbers. Basically, like addition law, the very first multiplication law is Commutative Law of Multiplication. This law says if we have two real numbers a and b and we want to multiply these two real numbers, then as a result of multiplication of these two real numbers, we will get the number that will also be the member of real set. So this is the expression of this law. For all a and b, both are the members of real numbers, and the product of a and b would also be the member of real set. So let's check with help of some example. Let we have two real numbers a and b. A is equal to minus 7 by 8 and b is equal to 13, and we will get the product of these two numbers, and the product of these two numbers is equal to minus 11.375. We know that minus 11.375 can be drawn on a number line, so this is the real number. I have already told you about number line in my previous video. This is the real number. So this means that the set of real numbers satisfy the Commutative Law of Multiplication. Let's move towards the second law of multiplication. That is the Associative Law of Multiplication. We can describe this law in very simple words by saying that if we multiply three real numbers in any order, we will always get the same result. Means order does not matter in case of multiplication for real numbers. This is the expression for all a, b and c. All are the members of real numbers, and you can see on the left side of equation the order of multiplication is different. On the right side of equation the order of multiplication is different, but both orders are equal according to Associative Law of Multiplication. So let's check with help of some real numbers. Let we have three real numbers a, b and c. A is equal to minus 7, b is equal to minus 6, c is equal to 4 by 5. Now first we will perform multiplication in this order. On the left side of equation a into b is c, and by using this order we will get the number that is equal to 33.5. Now we will perform multiplication by using this order on the right side of equation a, b into c, and by using this order we will also get the number that is equal to 33.5. Now you can see that the product of three numbers for both orders are equal 33.5. So this means that set of real numbers also satisfy the Associative Law of Multiplication. So this is the second law. Now we will talk about the third law. The third law is Multiplicative Identity. Basically, we can say multiplicative identity is that there is a number in the set of real numbers that does not change the identity of any other real number in case of multiplication with it. So let's check. This is the expression of this law. For all a is the member of R, this symbol represents there exists 1 is also the member of real numbers at the same time, such that if we multiply real number a by 1, then we will get a back. Means the 1 is the multiplicative identity that does not change the real identity of any number in case of multiplication. So let's check with the help of some example. Okay, let we have a real number 2 by 7. Now we know that there is a number present in the set of real number that in case of multiplication does not change the identity of other number, and that is 1. So we multiply a real number 2 by 7 by 1, then we will get the same number back, that is equal to 2 by 7. Or we can multiply multiplicative identity 1 by a real number, then in this case also we will get the same number back. So this is the multiplicative identity. Means there is a number in the set of real numbers that does not change the identity of other numbers of real set in the case of multiplication. So this is the law of multiplicative identity, and real numbers also satisfy this law. Now we will talk about the multiplicative inverse. Basically, multiplicative inverse of any number is just another number that creates 1 as a result of multiplication of actual number and its multiplicative inverse. We can also say the multiplicative inverse of any number is the reciprocal of that number. Now let we have a real number 4. So its multiplicative inverse would be 1 by 4, so that the result of multiplication of actual number and its multiplicative inverse is equal to 1. So this is the concept of multiplicative inverse. Now for real numbers, this law says that the set of real numbers should have the multiplicative inverse of each and every number. This is the expression of this law for real numbers. For all a is the member of real number that exists, its inverse should also be the member of real numbers, that the multiplication of actual number and its inverse is equal to 1, or the multiplication of multiplicative inverse and its actual number is equal to 1. So this is the expression. You can note, as a result of multiplication of an actual number and its inverse, we always get the multiplicative identity of same set, as 1 is the multiplicative identity of same set, okay, of real set. Okay, let's take some example to verify this law. Okay, let we have a real number a is equal to 5 by 19. So we need to check what is the multiplicative inverse of this number, so that after multiplication of this number with its multiplicative inverse, we will have 1. So that number is 19 by 5. We need to check either 19 by 5 is present in the set of real numbers or not. So the answer is yes. 19 by 5 is the real number, as this number can be drawn on the number line. So now we will multiply actual number and its multiplicative inverse, and as a result of multiplication of actual number and its multiplicative inverse, we will have 1. That is the multiplicative identity of real set. This means that real number also satisfy the law of multiplicative inverse. Now let's move towards the fifth and last law of multiplication, that is the commutative law of multiplication. This law says if we multiply two real numbers in any order, we always get the same result, means order does not matter. You can see the expression of this law for all a and b both are the members of R. Now this law says a into b is equal to b into a, means we just need to prove the left side of equation and the right side of equation. So let we have two real numbers, a is equal to 4 and b is equal to 10. Now we will first solve the left side of equation, a into b. So a into b is equal to 40, and now we will multiply b into a, the right side of equation. We can also see that b into a is also equal to 40. We can see that a into b is equal to b into a, means left side of equation is equal to right side of equation. So we can also see that real numbers also satisfy the commutative law of addition. So guys, this is all about multiplication laws of real number. After 5 addition and 5 multiplication laws of real numbers, now let's talk about one multiplication addition law of real number. This law says let we have three real numbers a, b and c. Now if we first add two real numbers b and c and then multiply the result of b plus c with a, we will get the same number as if we first multiply a with other two numbers separately and then add the product of ab and ac. Means we just need to verify that both sides of equation are equal for real numbers. This is the left distributive property and this is the right distributive property. You can memorize by looking at this number that the number by which we need to multiply the addition of other two numbers is at the left side, and in the right distributive property the number is at the right side. So let we have three real numbers a is equal to 7, b is equal to minus 6 by 4, whose decimal representation is equal to minus 1.5, and c is equal to 9 by 8. The decimal representation of 9 by 8 is equal to 1.125. Let's first verify the left side of first equation, that is a into b plus c. In this expression, we will first add b and c. The result of b plus c is equal to minus 0.375. Now we will add the result of b and c, addition of b and c with a. That should be equal to minus 2.625, means a into b plus c is equal to minus 2.625. This is the left side of equation. Now we will solve the right side of equation, ab in plus ac. AB, the product of AB is equal to minus 10.5 and the product of AC is equal to 7.875. Now we will add these two numbers. As a result, we will get AB plus AC is equal to minus 2.625. Now you can see clearly that the calculation via both orders, A into B plus C or AB plus AC, is equal to minus 2.625. So we can say that a set of real numbers satisfy the left distributive property. Now let's talk about the right distributive property. In right distributive property, we will first add A and B. A is equal to 7, B is equal to minus 1.5. And then we will multiply the result of A plus B with C. The result of A plus B into C is equal to 6.1875. Now we will solve the right side of equation AC plus BC. And after calculation, after solving this expression, we able to know that AC plus BC is also equal to 6.185. So this means both sides of equation are equal for real numbers. So this means the real number also satisfy the right distributive property. So this is the multiplication addition law. So today's lecture is all about this. Now we will talk about properties of equality of real numbers in our next video.